The presentation outline includes introduction, research gap, methodology, results, and future work. According to the International Renewable Energy Agency, the price of solar PV cells reduced 7 times from 2010 to 2020. Also, the efficiency of solar cells are improving significantly during recent years. Solar energy is the cheapest energy right now and cheaper than all fossil fuels. You can see it in the left figure. The UK and EU countries try to increase the share of renewable energy generation to have clean and sustainable environments. In the right figure, you can see the EU targets of renewable energy in 2020, 2030, and 2050, which is net zero. However, the UK did not meet the 2020 target yet by distance. We should increase the share of renewable energy generation dramatically, especially solar energy. Freitas and Burrito, who both are pioneers in the field of modeling solar energy in an urban area, published a review paper entitled Solar Facades for Future Cities in 2019. They explain why we should move toward using solar energy generation on both facades and rooftop of the building, and they believe researchers did not pay enough attention on this area yet. The first reason is that rooftops alone cannot be addressed all the energy the building energy demands, and second, facades represent an opportunity for the large-scale integration of PVs in city. So also as you know, PV cells are getting more and more cheap and efficient. For modeling potential of solar energy on facades, we need to know the effect of shadows on the facades, and for shading analysis, we need to have a model for the shape of the buildings. Researchers mainly used airborne LiDAR data, the cloud point transferred to raster and vector formats. So the FU studies into solar potential of facades can be categorized into either raster or vector methods. Both methods are used to analyze the solar energy using DSM or 2.5D models. In both categories, the rooftops were first extracted from LiDAR data, then based on the distance of rooftop and the ground, the facade are reconstructed. However, in this process, the facade structure and details are ignored. For example, the area below a balcony is unknown, but is considered as a facade. This study by Martinez is a good example of this kind of studies. For the purpose of assessing the feasibility of PV, building integrated PVs on facades, a 3D model with the level of detail of 2 is used. For shadow effect analysis, the data were obtained from Aquacity as a free sample. The PV models were arranged to cover the maximum possible area of facade and rooftops of a chosen building. The shadow effect and the total system loss were then determined using Skylion. Skylion is a plugin for Google SketchUp that allows to design PV models in 3D environment. And the shadow effect losses are unique for each building and are a function of building shape and surrounding neighborhood. All PV model with the shadow losses greater than 5% threshold were removed from to minimize the losses effect. The facades are categorized in the term of compass direction like NE, NW, SE, SW, and S according to their azimuths. PV system specifications such as a number of panels before and after threshold, the number of inverters, power, orientation of panels, and shadow losses can be seen in the right table. For determination of global teeth irradiance, GTI, which is the total solar irradiance received on the surface of a with the defined tilt and azimuth. Several satellite-based solar irradiance databases such as Cosmo, SARA, NSRBD, and CMSAF are used as shown in the figure. In these figures, the rooftop has the maximum estimated GTI, whereas the south-facing facades receive much higher GTI than north-facing facade, such as NE and NW. It can be observed that GTI determinations for all four databases are consistent, indicating that they will have a little impact on the ORC calculations. In this table, the annual AC generation total yield, GTI, total income, the system cost, and payback time can be seen. With the PV models usually have 25 years of lifetime, it would not be feasible to use north-facing facades, NE and NW, because these facades have a payback time of more than 25 years. However, there is not a significant difference between south-facing facades and rooftop. Given the increased area offered by facades and further decreases in the PV solar cells, it's likely that it will become economically feasible to use facades alongside rooftop of the buildings for generation of energy, solar energy in the near future. Further investigation into the feasibility are required, especially with the use of 3D models in which facade detail such as windows, can be considered. LiDAR data itself doesn't provide enough information for detecting windows, so we should use fusion of the LiDAR and image data. Also, we should use car or drone based LiDAR and image data to capture the facade details. Furthermore, since the building integrated PVs can be embodied in walls and windows for different costs, and more detailed estimations for system costs to be considered, such differences is required. So there are much more room for doing research in this area. Thank you very much.
I just had a question just about, perhaps, obviously you've shown in your paper kind of the feasibility of having solar on the facades of buildings, but just wondering more about the practicality. So obviously sort of, public acceptance of the solar PV, particularly in urban areas, I think is quite an important thing, particularly in terms of, policymakers thinking about increasing the mix of renewables. So I'm just wondering what your thoughts are sort of on, the practicability and feasibility in terms of the actual development and construction of them, and sort of how the fact that them being on, the sides of the buildings might impact that process.
Yeah, actually, as I told you, we need to increase the share of renewable energy in the next decade. So maybe 10 times. I didn't provide more information. So we should have a lot of farms, a lot of more panels on rooftops. We should see a lot of more development in this area. but the countries which have more sunshine and solar irradiance rich are in the pioneer area. So Germany, Portugal, and Spain are doing a lot of research in this area, and we should move toward doing more research in this. So as you show you, there is the picture. Let me show it again. This is a practical one. As you can see, this white material completely good for urban areas. It's not feasible. They are PV at all. So I think there are we can do it in the UK as well.
Okay, thank you. So are there there are successful examples of this?
Yeah,
in different countries?
yeah.